is going on page 31. Okay. And let's see. So we are going to identify the parent function and transformations, and then we're going to graph these. Okay. We're going to start when it says identify the parent function. There are 3 things to identify: the name of it, the equation for it, and the little sketch of it. Okay. So what is the name of this parent function? Absolute value. Okay, so this is absolute value. The parent function is f of x equals the absolute value of x. And then the little parent function sketch looks like this, right? Okay, you need all 3 pieces. Then we are going to identify the transformations. Okay, not a bad idea before you start writing them down to figure out how many you have so you don't leave anything off, right? So I've got, this is going to give me 1, so that's 1, this is 2, this is 3. So there's a total of 3. It's also a good idea to go from left to right so you don't leave anything out. So this first thing I have is a negative. I know that if I'm going to multiply by a negative, that means I have a reflection somewhere, right? Does this negative affect the x or the y? Y. And here's how we know that for sure, because this is where some people get confused. If it affects the x, that means it happens to x before whatever the operation is. And here it's the absolute value. So if I was to multiply by a negative before I took the absolute value, it affects x. If I do it after I take the absolute value, it affects y. Make sense? And if we change the sign on y, we reflect in what? X. So we reflect in the x-axis. So then I move on to this -1. What does that mean that I do? Right 1, because x is a big fat liar, right? And then this 7 means I do what? Up 7. Okay? Now, I'm not a big stickler about what order you write your transformations in. I think it's good to be consistent and go left to right, but it's fine if it's not in the exact same order I have. But here's what does matter, is that you have to do your translations left, right, up, and down. These 2 things have to go last. And it doesn't matter which one if you go up and down and then left and right, but all of the other things that could possibly happen have to happen before that. And I'll show you exactly why here in just a second. All right, so let's plot this. We're going to use our anchor points. So again, you can do your anchor points in any order. I'm going to do them the way that makes the most sense to me. I always start, if I can start with 0, 0, I'm starting with 0, 0. So here's 0, 0. And I also keep track of them on that. So I'm going to put my pencil on 0, 0. Then I reflect in the x-axis. Well, if I'm on 0, 0, my reflection takes me nowhere. Then I go to the right 1, and I go up 7. 1, 2, 3, 4, 5, 6, 7. There's my point. Okay? Notice what would happen if I did my translations first. If I went to the right 1 and up 7 and then reflected in the x-axis, this point would end up down here, and that's wrong. Okay? That's why I have to do all the other stuff first. So my next anchor point I would use would be 1, 1. So I'm going to go to 1, 1, and I put my pencil there. I reflect in the x-axis, so it ends up down here. Then I move to the right 1, and up 1, 2, 3, 4, 5, 6, 7. And then we go to -1, 1. That's my last anchor point. I'm going to reflect in the x-axis, go to the right 1, and up 7. And for absolute value, because it's basically it's a broken line, really, is what it is. I don't need anything else to help me get that shape. Okay. So then your ID, which should be around your neck, makes a great straight edge. You can just plop it up on the table and finish that. I'm going to cheat with my little line tool here. And don't make a little tiny V. Make it kind of the size of the grid, or close to the grid, so that we can get a good idea of what this looks like. All right, so then we fill out information about this. So my domain, is my domain basically all real numbers? Yes. So I'm -infinity to infinity. My range, where do I start? negative infinity. Somebody said 7 last period. You go bottom to top, least to greatest every time. So it's negative infinity to 7. Do I include 7? Yes, I do. Do I have any x-intercepts? Yes. How many do I have? 2. These are not points that I plotted on the graph, so I do not get to just select my points off of the graph. Okay, even though you may feel like your graph is perfect or whatever, they're generally right here, and mine do go through a pretty little point there, but that doesn't necessarily mean I'm correct because I didn't actually plot it using any transformations. So we need to go calculate this. An x-intercept is when y is 0, right? So I have 0 equals negative absolute value of x minus 1 plus 7. So I'll move my absolute value over. Okay, then I'm going to have 2 things here. X minus 1 equals 7, and negative x minus 1 equals 7. So this gives me x equals 8. This gives me x minus 1 equals negative 7, and x equals negative 6. Okay? And I should expect 2 because I can see that even if they didn't actually cross, and I did stop way up here, I could still see that they're going to. All right, so do I just write down my negative 6 and my 8? It says intercept. How does what form does my answer have to be in? Ordinate pairs, it's coordinates, yes. So it's negative 6, 0, and 8, 0, and 8, 0. Okay. Everybody okay with that? Do I have a y-intercept? Yes. Is it a point I actually plotted? Yes, so I don't have to do the math, and that's just at 0, 6. Okay? Got to be careful guessing off the graph. Do I have any critical points? Yes, I have an absolute maximum, and that is at 1, 7. Am I increasing anywhere? Yes. I start at negative infinity and go to what? 1, because I put the x value. Then I start decreasing at 1 and go to infinity. Now, on all of these, I wrote out the first part of in behavior because it's a lot of writing, and I knew that would take a while. But you still need to know how to write that out. So don't lose that understanding just because I have it written out a lot. But as x approaches infinity, what does f of x approach? Negative infinity. And as we approach negative infinity, negative infinity. Very good. All right. Any questions about those? We good? Okay, perfect. All right, so let's look at this next one. So what is this one called? Quadratic. It's the one you're probably most familiar with too. I don't know why that word's always so hard. So that's f of x equals x squared. And the parent function, looks like that. Mine's totally lopsided, but it doesn't matter. It's a sketch that I can follow. That's the basic shape. It's good enough. Okay. Your graphs should be a little bit more accurate, but your sketches, whatever. All right, so how many transformations do I have? Just 1, right? The only thing that's not the x squared is that 1/4. So if you have something that's being multiplied, that means it's going to be a stretch or a compression, and you have to decide which one, and you also have to decide if it's horizontal or vertical. So does that 1/4 affect x or y? X. So that means it's a horizontal something, right? Is it a stretch or a compression? Stretch, because x is a big fat liar, right? It looks like I'd be multiplying by 1/4 and it's going to get smaller, but x is a liar. It actually gets bigger. So this is a horizontal stretch by 4. Okay? We good? X is a liar. All right, so I start here at 0, 0. Well, at 0, 0, a horizontal stretch means that your x value gets multiplied by 4. And so 0 times 4 is just 0, so I'm still right here. My next anchor point is at 1, 1. I multiply my x value by 4, so my new x value is 4. I don't move 4. I go to 4, and then I'm right here at 1, 4. Okay? So my y value changes, my x value changes from 1 to 4. Don't count 4 spaces from where you are. So then I go to negative 1, 1. All I do is a horizontal stretch. So I have negative 1 times 4. That becomes negative 4. There's my point right there. 3 points are not enough for this. If this was absolute value, yes, but this is going to be a curve, and I kind of need to know where it curves. So my next anchor point would be where would make the most sense? 2, 4, right? So I'm going to go to 2, 4. Horizontal stretch by 4. My x value is 2. I multiply that by 4, and I get 8. Now, do I have symmetry with this graph? Yes. So I could count all that again, but notice that this is just a reflection of this point. So this point should just reflect over here to give me my last one, and I don't have to do all that counting as long as I understand my graph. Then I just do my best to sketch in what a parabola looks like, and I missed my point, but this is not an art class. It doesn't have to be perfect. It should be better than a sketch, but as long as you're making an honest effort and your points are correct, then you're fine. That's why having the points in the right place is so important. Okay. Any questions at this point? All right. Is my domain basically all real numbers? Yes. So negative infinity to infinity. My range is not. Where do I start? 0, and I go to infinity. Do I have an X-intercept? Yes, 0, 0. I plotted it, so it's there. If you have an X-intercept of 0, 0, you have a Y-intercept of 0, 0. Do you have any critical points? Absolute minimum. And that is also at 0, 0. Am I increasing anywhere? Yes. Where do I start increasing? 0. So 0 to infinity, and then I'm decreasing negative infinity to 0. And then my end behavior, both ends go to what? Infinity. So I'm just putting little infinities in there. Any questions about those? We good? All right, perfect. Let's flip it over then. All right. What's the name of this parent function? Square root. So we have a square root. So my parent function is f of x equals the square root of x. And remember that the square root function is just an inverse of part of the quadratic. So it's like the quadratic's laying down, but you only get the top half there. Okay, so how many transformations do we have? We have 3. We have this 3, this negative, and this minus 2, right? So there's 3 things I have to account for. So starting left to right, that 3, excuse me, is that horizontal or vertical? Okay, does it happen before or after I take the square root? After. I take the square root and then I multiply by 3, right? I know it comes before we're going left to right, but you got to think about when I calculate it, I'm going to do stuff in here, I'm going to take the square root, then I'm going to multiply it by 3, right? So it happens after I take the square root, which means it affects the y value. So if it's a y thing, that means it's vertical. Is it a stretch or a compression? Stretch, because y does not lie. And so it's a vertical stretch by 3. So yeah, when I say before or after, I don't mean left to right. I mean if you were actually going to calculate it. All right, so then this negative value I know is a reflection. Does that negative affect x or y? X, which means I reflect in y. And then this minus 2 means I do what? The right 2. Now when I do this, it doesn't matter which one of these two I do. The order in which I do these two doesn't matter. I just absolutely have to do that last, right? Because it's a left or right, up or down thing. Okay, so let's start here at 0, 0. Put my pencil at 0, 0. Vertical stretch by 3 means that you multiply the y value by 3. 3 times 0, 0. Reflect in the y-axis, I don't go anywhere. So the only thing I do is go to the right 2. That's the only thing you can do. My next one is 1, 1. So I put my pencil at 1, 1. Vertical stretch by 3. My y value is 1. I multiply by 3. My new y value is 3. Then I reflect in the y-axis, which puts me over here. Then I move to the right 2, and I just kind of end up right where I was. Now those 2 points are not enough. I need a third one. I don't want to use 2 as an x value because that gives me the square root of 2. What would be the next one that would give me a decent number? Okay, but I'm doing the square root. Like 2 gives me the square root of 2. 3 gives me the square root of 3. 4 gives me the square root of 4. Would that work? Does 4 work? Yes. 9 works too, and there's nothing wrong with 9, except that sometimes we want to kind of use the smallest ones we can, because sometimes, especially when we have stretches, it's going to go off the graph. So if you can use the smaller ones. So I can take the square root of 4 and get 2. But again, you can also use 9 and 3, and maybe you want to do an additional point. There's nothing wrong with that, but probably like the best, and it's a matter of opinion, would be 4, 2. And the way you figure that out is what would be the next one that would make sense in the parent function. So I'm going to go to 4, 2, and I'm right here. Vertical stretch by 3, my y value is 2. I multiply it by 3, my y value becomes 6. I reflect in the y-axis, it goes over here. I move to the right 2, and there's this. Now that's enough. If you wanted to do 9, 3, absolutely nothing wrong with it, but I only have to have 3. I know what this shape looks like, so it's going to look something like this. Okay. Everybody okay with that? Any questions about where anything came from? Alejandro asked me a question. Are you squinting because you can't see, or are you squinting because you have a question? Okay, that's why. Just that look on your face was either of confusion or trying to see. I couldn't tell. All right, everybody good? Right, so my domain, is it all real numbers? No. I start at negative infinity, but I go to what? 2. Do I include 2? Yes. Where do I start in the range? 0. And then I go to infinity. Do I have any x-intercepts? Yes. Is it a point I plotted? Yes. So it's just at 2, 0. Do I have a y-intercept? Yes. Now, it's not a point I plotted. Mine pretty much looks like it's 0, 4. I was dead on 0, 4 last period, but it really doesn't matter because it's not a point I plotted, so I have to go and actually do the math for it. Y-intercept is when x is 0. So that means that I get y equals 3 times the square root of negative 0 minus 2. So that means that y equals 3 times the square root of, well, negative 2 times a negative is a positive 2, and that's really all I got. So my y-intercept is 0, 3 square roots of 2. So you know what I know for a fact is the 3 square root of 2, whatever the decimal is, it's pretty close to 4. Because my graph isn't perfect, but I mean, it's kind of close. If I needed to actually plot that point, I would need the decimal. Otherwise, I need the exact number. Okay? We good on that? Questions? All right, do I have any critical points? I have an absolute minimum, absolutely. I have an absolute minimum, and that is at my x-intercept, which is at 2, 0. Am I increasing anywhere? No. I'm decreasing everywhere, so that goes from negative infinity to 2. Now, my end behavior, I copied and pasted all of this. Does this first part make sense for this graph? Do we approach infinity? No. What are we approaching? What is x approaching? 2. As x approaches, so we're going to change that infinity to 2. But here's one thing I realized I left off last time when we were doing that part. And it's not that huge of a deal because we'll get back to this. But when we approach 2, notice you're approaching 2 from the left. The parent function approaches 0 from the right, right? And eventually, whether we're approaching from the left or the right makes a difference. So what we're doing here, since we're approaching 2 from the left, you put a little negative sign kind of where the exponent would be, and that's what that means. I'm approaching 2 from the left, okay? So I'm just kind of telling you that stuff right now. I don't want you to stress out over it too much. I'm not going to test you on that right now. It's just something we're going to start seeing more and more of, okay? So as I approach 2 from the left, what is y approaching? 0. Okay. Do we actually get there? Yes. Does it matter? No, because it's all about what we're approaching. So as x approaches negative infinity, what does f of x approach? Infinity. Okay. Questions? All right. Let's look at number 4. What is the name of this one? Cube root. So this is f of x is equal to the cube root of x. Now, my guess is you are probably more familiar with a cubic, even though you should have seen cube roots. Now, a cubic, this is what my parent function would look like this. But this is an inverse of that, so it looks like this. It's laying down. Okay. How many transformations do I have? 3, okay, because this little 3 right here doesn't count because it's part of the cube root itself. All right, so I start with this 2. Does this 2 affect x or y? X. So that means that this is horizontal. And would this be a horizontal stretch or compression? Compression. Good, because x is a big fat liar. So it's a horizontal compression by 1/2. Then I have this 1. What does this mean I do? Left 1 and then up 4. Any questions about those? All right, so again, I'm going to start with 0, 0. My stretches, compressions, and reflections don't do anything when you're at 0, 0. At 0, 0, it's only the translations that do anything. So you're going to go left 1 and up 4. Then I'm going to do 1, 1. So I'm at 1, 1. I have a horizontal compression by 1/2. My x value is 1. I multiply that by 1/2, so now I'm at 1/2, 1. Then I go to the left 1 and up 1, 2, oh, shoot. Sorry, I leaned on the board. Then I go up 1, 2, 3, 4, and I end up right there. Okay? If you're not sure where something came from, let me know. I know sometimes you're following along and you look down to write something, you look back up, and you're like, I don't know what the heck's going on. All right, so then my next anchor point is at -1, -1. Horizontal compression by 1/2. So now I'm at -1/2, -1. I move to the left 1 and up 1, 2, 3, 4. Are those 3 points enough? No. I need 5 on this. So when I go to figure out my other one, I'm not going to use 2 as an x value because it'll give me the cube root of 2. I don't want that. What's the next x value that would give me a decent y value? 8. So I'm going to go to 8, 2, right here. My horizontal compression by 1/2, my x value becomes 4. Then I go to the left 1 and up 1, 2, 3, 4. Okay? Let me know if I need to do it again because you're looking up and down. Good? All right, so then what would my last one be? What would that ordered pair be for my anchor point? -8, -2. Dang it, I keep leaning on the board. So I'm going to go to -8, -2. Horizontal compression by 1/2, so now I'm at -4, -2. Then I move to the left 1 and up 4. And then I have to think about, shouldn't have to think too hard because you should have it drawn right there. What does the parent function look like? It's laying down, right? Because this is what I see sometimes. These points are all done beautifully, and then you try and draw something in that looks like that, which makes absolutely no sense and tells me you have no clue what's going on. So it's got to look like this. Again, not hardcore judging your pictures if they're not perfect, but if your shape isn't anywhere near, that tells me you don't really know what you're trying to draw. Okay? We good? Any questions? Okay. Is my domain all real numbers? Yes. Okay, so I'm going to put -infinity to infinity. What about the range? It's the same, right? -infinity to infinity. All right, do I have an X-intercept? Yes. I don't see one on the graph, but is it going to cross the x-axis at some point? Yes, I should have one. So I have to go figure out what that is. My X-intercept is when y is 0. So I get 0 equals the cube root of 2 times x plus 1 plus 4. Okay? Now I know a couple of things about this. I know, first of all, I should get a negative number clearly from my graph. And it's got to be, I would say, least less than negative 10, because I feel like I'm pretty good on that on my graph. So I'm going to subtract 4 from both sides to get negative 4 equals the cube root of 2 times x plus 1. How do I undo a cube root? Cube it. What's negative 4 cubed? Negative 64. Good. Negative 64. That's equal to 2 times x plus 1. So I'm going to divide both sides by 2, get negative 32 equals x plus 1. So x is equal to negative 33. All right, you got to be able to solve basic equations here. So my x-intercept is negative 33, 0. Do I have a y-intercept? Yes. Is it a point I actually plotted? No. Okay, so that means I need to go and find it. I know about what it is, but that's not good enough. So my y-intercept is when x is 0. So y is equal to the cube root of 2 times 0 plus 1 plus 4. Okay. So 0 plus 1 is 1 times 2 is 2. So y is equal to the cube root of 2 plus 4. And there's really nothing else I can do with that. You just got to make sure that your cube root sign doesn't look all crazy, and it's obvious that the 4 is not underneath it. Okay, there shouldn't be a question there. So my y-intercept is just 0, cube root of 2, plus 4. Okay. Sometimes your answers are ugly. I mean, it is what it is. Any questions at all? All right. Do I have any critical points? I have a point of inflection. Very good. I don't have any extrema, but I do have a point of inflection. And that is at negative 1, 4. Am I increasing anywhere? Yes, everywhere, right? So negative infinity to infinity, which means this is none. And then my end behavior, as x approaches infinity, what does f of x approach? Infinity. And as we approach negative infinity, negative infinity. Very good. All right, so get that finished up. I'm going to give you your second page. Like I said, if I'd have given them both out at the beginning, somebody would have started on the wrong one, and you know, I only have so much patience for that. Bless you. All right, there you go. And we're not going to do all of these. I'm going to skip around a little bit. Mm-hmm. Oh, did I not count right? I'm sorry. Oh, you need tape. Oh, okay. Well, here you go. Y'all gonna have to share with that table. Give it back to them when you're done. Okay. So we're going to do number, oh, that's not. We're going to jump to number 6. So you should be on what it says page 3, which is going on 32. And we're going to start with the second one because we don't have time to do them all. Okay. All righty. So what do we call this parent function? Quadratic. This is f of x is equal to x squared. And my parent function looks like this, right? All that should be pretty simple, hopefully. How many transformations do we have? 4. Okay, so I'm going to start with this negative. This negative is going to be a reflection in which axis? The x-axis, because it affects the y. Very good. Okay. This 3, is it a horizontal or vertical something? Vertical. And then is it a stretch or a compression? Stretch. stretch by 3. Then this 4 means I do right 4, and the 6 means I go up 6, okay? Everybody good with all that? All right, perfect. So let's graph. We're going to start with 0, 0. So remember the reflections, compressions, stretches, that none of that affects 0, 0. All that is going to affect that is if we go the right 4 and up 6. 2, 4, 6. So there's that. Then I'm going to do 1, 1. Okay, 1, 1. Reflect in the x-axis, so I end up at 1, negative 1. Vertical stretch by 3. My y value is negative 1. I multiply that by 3, and I get negative 3. And I'm here. Then I move to the right 4 and up 6. We good with that? If you're keeping up with which anchor points are which, when you get to this one, isn't this one just a reflection of that one? So when I'm here, I can just say, well, then this is where that other point has to go. If you're not comfortable with that, then you count like you need to, okay? Because that can get you in some trouble sometimes if you're not careful with that. All right, so then what's my next anchor point? 2 what? 4. Okay, so I'm going to go to 2, 4. I'm going to reflect it in the x-axis, so now I'm at 2, negative 4. Vertical stretch by 3 puts me at 2, negative 12. Now I've gone off the graph. That doesn't mean I just stop, because look what's going to happen. I'm going to go to the right 4, and then I'm going to go up 6. If I'm at negative 12 and I go up 6, where do I end up? Negative 6. So then I'm just going to double, because I was off to the side. Let me see. I went to the right 4, and then I should be at negative 6 right there. Okay. Can I use symmetry there too? Yes, I can just move over 1, and then I'm right here. Okay. So then I'm just going to do the best I can to make it look like a parabola. Whoop. Well, that's kind of weird, but that's okay. I'm going to leave it. As long as my points are good, I'm good. All right, now we're not going to go through all this because I know you can get most all of this. We're going to look at the intercepts here, make sure we can handle these correctly. I have X-intercepts. I have 2 of them. I do not get to guess off the graph. I got to go find them. X-intercept is when y is 0. So 0 equals negative 3 times x minus 4 squared plus 6. So I subtract 6 from both sides. I get negative 6 equals negative 3 times x minus 4 squared. Divide by negative 3. 2 equals x minus 4 squared. How do I undo a square? Square root. So when I do that, what does the left-hand side look like? What do I write first? Plus or minus the square root of 2 is equal to x minus 4. Oops. So now I add 4 to both sides, and I get plus or minus the square root of 2 plus 4 equals x. If you don't do the plus or minus, you should notice you get one answer when you know you're supposed to have 2, right? So my x-intercepts are going to be plus or minus 2, square root of 2, plus 4, comma 0. That counts as 2 points. Okay. Am I going to have a y-intercept? Yes, it's going to be negative, and it's going to be a pretty small negative number. So y-intercept is when x is 0. So I'm looking for f of 0. That's equal to negative 3 times 0 minus 4 squared plus 6. So negative 4 squared is 16. So negative 3 times 16 plus 6. What is negative 3 times 16? Negative 48 plus 6 gives me a negative 42. So this is at 0, negative 42. Okay. What questions do you have? And you should be able to fill in the rest just fine. Okay, so remember, just because you go off the graph doesn't mean you won't come back to it, and you got to actually calculate these things. All right, so let's go to, flip it over And I think I want to do number 7. Let me see. Yeah, we're going to do number 7. All right, so what is this parent function? Cubic. So this is f of x is equal to x cubed. And my graph looks something like this. How many transformations do I have? 3. What is that 1/2? Say vertical compression by 1/2. Then that 4 means I go left 4 and then up 5. Okay. So I started 0, 0. The compression doesn't do anything. If I go to the left 4, up 5. Then I'm at 1, 1. Vertical compression by 1/2, so now I'm at 1, 1/2. I go to the left 4 and up 1, 2, 3, 4, 5. Can I use some symmetry here? We've got some rotational symmetry because this was 1, 1. This is -1, -1. So this point has to be right there. Right. Or you can count it all if you're not comfortable doing that because you definitely want to get them in the right spots. All right, so then what's my next point? 2 what? 8. So I'm going to go to 2, 8. Vertical compression by 1/2. So now I'm at 2, 4. I go to the left 4 and up 5. I could use symmetry there too, but I'll use -2, -8. That puts me right here. Vertical compression by 1/2. Left 4, up 5. And then again, you have to know your shape so that you don't try and make this one come in like this, because that didn't make any sense. This one's the tall one, and it looks something like this. Do I have an X-intercept? Yes. So my X-intercept is when y is 0. 0 equals 1/2 times x plus 4 cubed plus 5. So I can subtract 5 from both sides, and I get -5 equals 1/2 times x plus 4 cubed. What would I do next? Multiply both sides by 2. So I get -10 is equal to x plus 4 cubed. How do you undo a cube? Cube root. Can you take the cube root of a negative number and get a real number? Yeah. So I've got the cube root of -10. Do you know what that is? Nope, me either, and it's a decimal, so we don't care. That's equal to x plus 4. So I subtract 4, and I get x equals cube root of -10 plus 4. Oh, wait, I'm sorry. What did I do wrong? -4. Oh, dang it. Sorry. I don't know what I said. Hopefully I said it right. I subtract 4, so it should be -4. So this gives me cube root of -10 minus 4, comma 0. Right? Now my y-intercept. That's f of 0. That's equal to 1/2 times 0 plus 4, which is just, I'll just put 4 cubed for space, plus 5. What's 4 cubed? 4 times 4 is 16, times 4 is 64. So I get 1/2 times 64 plus 5. Good. So it's 32 plus 5, which is 37. Which makes sense that it should be a large positive number based on our graph, right? What questions do you have? Anything? Got to do the basic math that goes with it. Can't just be about all plotting points, but your points have to be correct. Right. Any questions at all? Alrighty. So while you are taping stuff in, I may have a chance to show you at least one of these and kind of what I wanted to show you. Here It gives you the parent function, and you're supposed to graph this function, right? What does that 2 mean we do? Go to the right. So remember, I always start with 0, 0. If I try to go to the right 2 here, you see how it stretches? It's not moving it. So I'm going to click. You can always click Start Over. The only way you can actually translate is if you grab the green one and move it over like that. Okay, does that make sense? And you'll kind of notice that when you do it. So this one, I'm supposed to reflect and then move. What do I reflect in? Y-axis. So you grab one of the blue points. It doesn't matter. This one's the easiest. I'm going to reflect it over the Y-axis, and it takes all the rest of them with it. And then I can move down 3. Okay, so you just kind of play with them that way. Oh, and also when you do your compressions, don't grab the green when you grab the blue ones to do your compressions there. And this one, I don't expect you to know the actual equation. That's why it has f of x. But it tells you that the solid graph is the parent function, and then you have to figure out what happens to it. Okay? Y'all can handle that. Have a great day. Don't forget your phones.